Hello, everyone. Welcome back to Navigating the Future, the T-Kartor podcast, where we talk about how geospatial technology, data, and innovation are shaping the world around us.
And I'm Red Curry, and I hope my phone doesn't go off while we're having this podcast. I think that's today's technology. But I am really excited to join my co-host, Sydney Sanker, also sometimes known as Sydney Bailey. Sydney, I said that right?
Yeah.
All right. And
That's right.
don't cut any of this. This is the good stuff. So today we're diving into a topic that's gaining a lot of momentum. And I'm really excited to be talking about vibe coding in tech. And what does that mean for geospatial innovation?
And we're joined by Fredrik, who has been building and experimenting at the intersection of maps, data, and software for many years.
Fredrik, welcome to the show. It's really great to have you with us. I finally locked you down, right? So we finally got Fredrik on the phone. It's taken a while to get him as a guest, but we're really happy to have you here.
Thanks for having me. I'm looking forward to our talk, and I hope I can bring some value to the discussion and obviously to the listeners as well.
Oh, I know you will, my friend.
So, Fredrik, people are hearing the term vibe coding more and more. What does that mean to you?
First off, I've somewhat people are talking about vibe coding today in a negative way, but I'd like to say that vibe coding is in its original. It's good. It lowers the threshold of getting people starting to work as developers, or not developers, but developing solutions. But in short, vibe coding is a way of prompting to get code and solutions and write code. So you iterate the coding by talking or prompting to AI and get the results that you want. So yeah, a prompting to code, I say.
And how does that differ from traditional software development approaches?
It's very different. The threshold for the people are much lower. So it speeds up building proof of concepts. And also originally or before, you had to know a lot of code. You need to have the knowledge of how to write code, but now you can express it through talking or prompting and getting the result instead. So it's very different of how you did originally when it comes to coding, I'd say.
What tools or workflows are enabling this rapid prototyping culture today?
So I say for traditional developers, they use things like Copilot or Claude Code or ChatGPT. So they can ask these different AI tools to help them build code stubs to speed up their daily work. But for people who are not developers, they would use solutions like Replit or Lovable. So those are solutions where you prompt and the AI builds out the full solution from the beginning to a full workable proof of concept. And I'm saying proof of concept because as we get deeper into the discussion, I'd like to highlight what the difference is between building a proof of concept and a fully production worthy product. So it's Replit, Lovable for normal people, not the developers. And for developers, you can use Copilot, Claude Code, or ChatGPT, I'd say.
You know, when you said prompting and as you explain it, in my world, in marketing and sales, this thing is an ever-growing sort of tools that we use, and AI, and it really has taken over a lot of what I do in my work. And I'd love to know personally, have you personally used AI or rapid prototyping tools to build geospatial ideas? Because this is something that's evolving, as you mentioned, right? Speeding us up. It's making us faster. It's helping us get out there. Tell me maybe some of the ones that you've used personally that you like, and how is it helping to build?
Yeah, I'll mention three. I've built multiple because the good thing about vibe coding is that you can have an idea. And then you can get this idea up and running quite quickly. So as soon as I run into an idea, I try it out. But I'm going to mention three of them, and they're quite different. I'll start with the first one, which is many years ago I saw a art project where they let out virtual ships that were floating around at sea, and that gave me the idea to do the same thing with balloons. So people could let up virtual balloons, and these balloons, where they went, were dependent of different winds around the world. So I used APIs from different weather models to get the balloons to travel around the world. And having this idea and prompting the AI, I could build this solution and had something up and running in 2 days or something like that. And actually, there were a couple of school classes that started using this as part of their geography classes. So the kids could let loose these balloons, and depending on where they turned up every day, they read about that area that their balloons were in. So that was one solution, and you know, it would have taken me weeks to develop or code it myself, but this was easy. Another one was a solution called Track Challenger, where people could connect their Strava account. So every time they were out biking or walking or running, their distance were synchronized up to this solution and then mapped out to a route from the source of Thames, the river in the UK, from the source to London, which is 300 kilometers or 160 miles, something like that. And so for example, the three of us, Sydney, Red, and me, we could do our different activities in different parts of the world, but it would show up on the same map, and we could actually see, you know, we could compete, but virtually and see it on a map. So that's another one. It's just a social fun things. But what I saw when I tried it out is people start talking about, we're at the same place, you know, maybe we should go to a pub and take a beer because we are, you know, in the same part of the UK. So it was a fun one. A third one is a flight tracker I did, and that is it was I needed test data for our Iris platform to test some different use cases for customers, and I needed test data because we work with a lot of sensitive customers or customers that have sensitive data. So when trying things out, we can't use their data. We need to use our own data. So I built a vibe coding flight tracker, which just positioned different airplanes on a map, and then it enabled me to export this as GeoJSON, which is a format for positioning data, and so that it enabled me to create a lot of demo data, which was just demo data, but it was good enough to test it for customer use cases. So those are three different use cases that I've done, but I've done multiple. As soon as you have an idea, you can build it with vibe coding. So yeah, so those, yeah.
Well, I'd love to ask them, what surprised you most about how fast things can be built now? Was it accuracy? Was it creativity? Was it anything? I mean, I'm not sure. I'd love to know, though, what surprised you most about how fast things can be built today?
I'd say the from zero to proof of concept is down to a couple of days or even hours now. So that really surprised me, how fast you can get something up and running just based on very, very simple prompting. And it's also extremely rewarding to see how things play out that quickly. But what I did find out, and part of what surprised me, is that you really need to put a lot of thoughts into how to formulate your ideas, and so you, because the AI obviously isn't thinking, but in a lot of cases, if you're not, you know, being very vocabulary about the framework of which the solution should be within, then it's easy for it to build things that you really don't think about and it goes down a route that you're not thinking about. So you need to put a lot of thinking into your and formulating the idea, because otherwise you will just use enormous amount of time of fixing bugs that because the AI doesn't think, it just guesses what you think.
I'd love to talk a bit as we flip into sort of the geospatial aspect and why geospatial is different, and why potentially you could maybe help me understand why is geospatial software perhaps harder to prototype casually than the other applications.
Yeah, so I mean, we've gotten used to things like Google Maps, OpenStreetMap, and from a developer perspective, we have a wide range of available software libraries. But working with Geospatial is like going down a rabbit hole. I mean, you can build 80% based on having very general knowledge about geospatial stuff. So for a proof of concept, it will work to have a vibe coding or do the vibe coding. But for the last 20%, it requires deep knowledge of geospatial things. So I think that it's easy to make the assumption that it's easy to build, but if you don't know the trade, you will hit, it will be you will run into a lot of problems down the road.
Yeah. And with that said, right, I mean, there are problems that come up and there are risks. And I really want to touch on what you think some of the risks of moving fast when you're dealing with spatial data, because there are things that can be missed.
Yeah, absolutely. So spatial data is fundamentally two things, or tied to two things, time and position. So time is usually the easier one. Even across time zones or orbital timestamps, you can normalize it fairly quickly. But position, however, is very, that's where things gets tricky, especially when you don't do your homework. So because the way we see position is always dependent on the projection we choose. So there's no neutral view of the Earth. Every projection distorts something. It could be area, shape, distance, or direction. So when you're in a hurry, you risk building analytics, decisions, or visualizations on top of distortions you haven't even noticed. So in other words, what you see depends on how you choose to see it. And if the wrong projection sneaks into the workflow, suddenly the story changes. Assets appear closer or farther away, areas might look bigger, threat envelopes shifts, or logistic routes seems optimal when they're not. And this is before we've even added things like elevation models or similar. So that's the core risk of moving fast with spatial data. You can get right data with the wrong geometry and missing key components. And once the visualization looks convincing, people tend to trust it, even if the math and underlying data is off. So there is a real risk of moving too fast, I say.
Where do you think people underestimate the complexity of mapping systems?
I think a lot of people underestimate it because of the ease of access. I mean, we're spoiled with smartphones and having geolocation up to date in our pockets. So easy to use doesn't mean easy to build or implement. Obviously, vibe coding will further build the underestimation of the complexity. So I mean, it's a double-edged sword. But yeah.
I'm curious, in what domains does precision really matter? And I mean like defense, aviation, smart cities, and wayfinding, things like that.
I think that, as with everything, you get back what you put in. All domains that need quality needs high precision, especially in cases where data flow between different systems. So I think that, if you want the quality, you need to put down the work and the time with it. And that goes independent of the industry, if it's defense, aviation, or smarter cities. If you want quality, you need to have the precision, and then you need to put down the work.
So how do you balance experimentation with reliability in geospatial projects?
That's a good one. I think you need to be very strict about the fact that experimentation is just that. It's easy to get tempted to assume that a proof of concept is good enough and sneak it into production. I've seen that multiple times. This works, and then suddenly it's in production. But in reality, you're playing with fire. because this nearly always builds a massive tech debt. So you're tempted to put vibe coded things into production, but they are not, in almost all cases, they are very hard to continue building on. So that's and that is specifically a problem for geospatial projects, but it's all over, independent of other types of projects as well.
That leads me into where vibe coding works in maps. So where do you think vibe coding does make sense in geospatial?
I think it speeds up for experienced developers. So I mean, we have a lot of great developers in T-Kartor, and for them, this type of tool will help them to speed up their work. For product department, they can do tests more rapidly. They can test ideas earlier. But to create valuable solutions for our end customers and users, we need developers with deep knowledge on the geospatial subject. So there's just no room for guessing here, and so we need to quality assure all the code that is written both by people but also by AI.
What kind of proof of concept projects benefit the most from fast iteration?
I say that totally new and untested ideas or new independent modules or integrations are where we see the biggest benefit. Where it's hard to add vibe coding or AI is within complex workflows with built-in business logic, because you have business logic in code, and it's not too seldom not very well formulated. So adding new parts into that workflow is better done by people today. So it is for totally new ideas to iterate and test on new stuff, I'd say.
And can you share any examples of rapid prototypes that help to move any ideas forward?
Yeah, absolutely. A while back, or it was actually quite recently, we did a integration with a BMS, a battle management system. So we had our T-Kartor Iris, which provided the battle management system with geospatial data, obviously, and the battle management system had a well-documented API, so we could use the vibe coding environment to point it to the API and say, okay, we want to do this, and the AI read through the API documentation, and there's no secrets about the API documentation and stuff like that. So we were not showing it any end user data. We were just using the API endpoint, so we could get a integration up and running as a proof of concept quite easily. So that's what it was, a quick one, I'd say, a quick win.
You know, I think our audience is curious. Now we've gotten into the vibe coding and how it works in maps. So I think our audience would be curious. How can this approach really help cities, startups, product teams to test spatial ideas quickly, Fredrik? I'd love to know that.
And I've touched on it a bit. I think that it will enable a wider range of functions within a company or group to test the ideas. So it's not just the product department or the development department, but even HR or other functions within companies can do tests to help them solve the problem. So it lowers the threshold of validating any idea or testing workflows to be more efficient. So I think that's where we will see the quickest wins and biggest wins going forward.
Yeah, and maps being sort of visualization and storytelling. What's the role of visualization and storytelling in the early stage of geospatial prototypes?
I'd say it's key. By validating your ideas, if you want and need to put in the work and effort to actually build a fully functional, secure feature solution. Vibe coding enables you to build something that functions and something you can demo and show up. If the idea doesn't fly, after you've tested it or showed it, you can either iterate on it, but else you can just throw it away and say this didn't work. So enabling departments or other functions within the company to test it, you will help them with the storytelling, and just throw away bad ideas and put more effort into good ones.
And we've talked about the bone, but putting the meat on the bone now, right? Prototype to production, and actually getting down to what truly matters. And I'd love to cover an idea with you: the gap between the geospatial prototype and the deployable system. What is that gap right now, as you see it?
It's an enormous gap. At the current state of AI, I'd say any code needs to be validated by real developers. So from a security perspective, you need to check and verify all code and do a proper quality assurance. Prototypes in general are often built to solve very specific use cases. When it comes to vibe coding and AI, they seldom handle anything outside of these very specific use cases. Obviously, AI is getting much better by the day, but you also need to make sure that you're diligent and strict to differentiate geospatial data and the workflow handling it. So I think you need to be very, as I said, very diligent to make sure that when you do these things, you're focusing on building workflows and not handling the data that our customers are using. So there is a difference that you don't want to leak any data out to these platforms. So there could be an issue with that, and that also makes it pretty hard of going from prototype to deploying it in system production workflows.
You reminded me of something when you said, AI better by the day.
Yeah.
And I think back to the human in the loop always, especially now where we overtrust and we don't verify. What steps now do you think are often overlooked when we move from the demo to operational capabilities? Because I think there are some things there that do get overlooked. Do you agree?
Yeah, absolutely. I mean, the sheer amount of time it takes to secure the quality of what's been built, that is overlooked. Because, again, I mean, the vibe coding enables you to see things quite early on, and they often look very good. But the security or securing what has been built, it needs to be done very manually today. And again, I mean, these creations, they often handles very specific use cases, but in production systems, they should hold a line independent of what you throw at it. So securing that, it takes a lot of time.
And everybody's AI, and what tool they use and where they go and what they do and how powerful it is today and how they're using it. And for me, the dangers in the adoption, or the earliest adoption and the trust. How do enterprises, how do commercial companies, how do governments evaluate whether a geospatial solution is production ready? How do you believe in it? How do you know that it's not snake oil, I guess you could say?
Yeah, and again, I mean, it's down to validating, verifying security and compliance with standards. It needs to validate towards operational readiness, and also whether it will work 24/7. You will need to do validation on user workflows. Does it work to support the actual mission, independent of mission? So all in all, companies, enterprises, governments, they need to have a structured QA structure process. So quality assurance. So I think that the quality assurance part of any implementation of AI will need to grow. So some people will lose their jobs, but they might go over to do the quality assurance part. I don't know. But in short, this process needed independent of vibe coding. It's just that now you need to validate it at a later stage, I'd say.
What lessons should product teams take from vibe coding, and what should they ignore?
Again, AI and vibe coding is lowering the threshold of getting things done. It enables more tests, more innovation at higher speed in product iteration. Product discovery will give better results as proof of concepts are more functional, and you can even solve end user cases during that process of product discovery. But more of everything means there's a risk. You need to nail down your QA process again and keep delivering high quality products that securely helps customers to solve their work challenges, basically. So I think that, again, QA is fundamental, but it will speed up the initial process of product teams and help them to focus on what's focus on the use cases that actually solves problems for customers.
Also, how can organizations institutionalize innovation without sacrificing trust and accuracy?
I mean, rapid innovation is key for any organization today, and vibe coding is an excellent tool for that. But as mentioned before, you need a solid process to keep things secure. So that is, if you nail that down, that will answer the question, I'd say.
So do you think AI will eventually build geospatial systems end to end, or will we always need a human in the loop?
I think AI will for sure build end-to-end solutions, but we shouldn't forget that AI is just another extraction level of programming. So we've gone through the different steps where we, when I was a kid, we were doing like machine code, and then we were doing assembler and then C, and then we were getting into more visual ways of making computers do what we wanted. AI is just a level on top of that. So we'll get more code done in shorter and shorter cycles, and the solutions are getting better. At some point, we will have full end-to-end solutions built based on people just prompting something, and you'll see the result. And I say that they are still in some way a human in loop, because the idea needs to be communicated, and I think that people will be the communicator of ideas going forward for a very long time.
To get more specific, how do you see AI changing geospatial workflows over the next 5 years?
I think that a lot of geospatial workflows are governed by different standards. So, for example, we have the OGC standard, we have ISO standards, we have the NATO standard. But when we reach a point in which we can trust AI to adhere to these frameworks and standards, I think we will see a lot of optimized solutions and tailored workflows.
So the future of AI and geospatial are upon us, and we're just scratching the surface. I would love to know, Fredrik, what advice would you give teams exploring AI-driven geospatial development today?
I'd say that you should set aside time each week. It could be really, really basic stuff like interacting with ChatGPT. So you could ask it for help in product discovery to formulate a problem. But you could also get it to even ChatGPT. You can get it to build like a web page to help you visualize some of your ideas you have, and you can run this locally. So you can get ChatGPT to build it, and then just drag and drop the file it builds into a web browser, and you can see it. And it will actually help you implement geospatial things like if you want a map, it will implement that through leaflet JavaScript or pull OpenStreetMaps into it. So you will get everything that you need. So I think that putting aside 1 or 2 hours every week to just get started, but the security requirements are high within the industry, so you should never share any data with external AI platforms, especially customer data. Obviously, often we don't have access to that anyhow, but it could be data that is you should see all data as sensitive. So there needs to be an understanding about that, how to differentiate that within your organization. But besides that, the 2 hours a week, I think that's a real good start, because then everybody from sales to product to tech to marketing, you start playing with it and you get used to it, and then you see where can I use it and how can I use it without being, without using it so that everything you build is just generic stuff, but you actually use it as a tool to help you be more effective, I'd say.
Yeah, and then Sid and I were talking about how it helps us with our creativity and how we help push our processes and be better with our ideas and our innovation and our creativity and all of that wonderful stuff. And we were discussing, we both wanted to know what excites you most about the future of maps and AI together. I think that's something our audience would love to know more about.
Yeah, I'm looking forward to seeing a lot of new solutions that help end users with very specific use cases. A lot of time and resources are today being consumed by repetitive work within the industry. Often legacy workflows that have been the same for ages. And I have tons of examples of that. Customers with specific workflows and we ask them, why are you doing this? And they say, okay, we've always done it. And there is often a reason for it, but AI will enable them to help them automate that, and that will save them time. And that specific workflow might not be something that we or anybody else within the industry should add as a standard to our platforms, because it's so unique for that customer. But if the customer themselves can build it and then use this new solution to integrate it to our solution or any other geospatial platform, that will make the customer more efficient. And it will make our products better as well, because we don't need to implement those very specific workflows. So I'm looking really much forward to seeing customers use AI in a way that helps them in their workflow on a daily basis. Absolutely. And that will, enable a more secure and smooth handling of the vast amount of geospatial data that we're handling at the moment.
That's incredible. And that gets us to our time. And I really want to say, Fredrik, this has been an incredible conversation. And to our audience, going to tease it out, there will be another one coming shortly. We're going to bother Fredrik for another chat shortly. We'll be teasing that again, like I said, on social media. But thank you again for sharing your perspective on vibe coding and geospatial innovation and the two coming together, and all the insight you've provided. It's just really amazing.
Thank you. I hope it gives value to someone. And it was a pleasure talking to you guys. Thank you very much.
And if you enjoyed this episode, make sure to subscribe to Navigating the Future wherever you get your podcasts.
Yeah, thanks, Sid. And we're on Spotify, we're on YouTube, right? And you can actually ask us any questions that you have through our LinkedIn channels. Reach out to Fredrik personally. Sydney, of course, reach out to Sydney. Myself, we're happy to connect you with anybody you want to ask more about. We'll be back soon, though, with more conversations about maps, technology, and how we navigate what's next. Thank you all again for listening, and we'll see you next time.